Lesson 18.3, Task 2. Use the discriminant. In the quadratic formula, the expression b squared minus 4ac under the radical sign is called the discriminant. It determines the number of real solutions of a quadratic equation of the form ax squared plus bx plus c equals 0. All quadratic equations have either two real, one real, or no real solutions. All right, so again, this is very important. This is called the discriminant. This is a new term that you need to be familiar with. All right, and you also need to know that every quadratic equation can have two real, one real, or no real solutions. All right, so the chart shows possible values of the discriminant, the number of solutions of the associated quadratic equation, and a sample graph of f of x equals ax squared plus bx plus c. All right, so the discriminant again is b squared minus 4ac. If the discriminant is positive or greater than 0 just means positive. So if the discriminant is positive, it's going to have two real solutions. If you look at the graph, you're going to see that it crosses in two places. So it crosses the x in two places, so it will have two real solutions. Remember, your solutions are x equals and whatever those solutions are. All right, if your discriminant, b squared minus 4ac equals 0, it means it has one real solution. So your vertex is going to be somewhere on the x-axis. So it's going to touch one time, so it will have one solution. And then if your discriminant, b squared minus 4ac, is negative or less than 0, you're going to have no real solutions. So that means the quadratic, if you graph it, it's going to be either up in a quadrant above the x-axis, or it may fall down here and be upside down and be below the x-axis. But the point is there's no real solution, so it does not cross the x. All right. And this just says in Algebra 2 you're going to learn something about complex numbers, but we don't need to worry about that right now. So how does the graph of f of x equals ax squared plus bx plus c tell you how many real solutions the equation has? All right, so the number of real solutions is equal to the number of times the graph crosses the x-axis. The number of real solutions is equal to the number of x and y intercepts. The number of real solutions depends on the quadrant in which the minimum or maximum graph lies. So again, if you look up here, this one has two solutions because it crosses the x-axis twice. So the first answer, the number of solutions is equal to the number of times it crosses the x-axis. So that is the correct answer. All right, for x squared minus 2x minus 15 equals 0, complete the statement to show the values of a, b, and c. Remember, a is your quadratic term, so whatever value is in front of x squared, when there's no number, you assume it to be a 1. The b is in front of the linear term, or that's considered your linear term, so it's the number in front of your x. That does include the sign, so this one would be negative 2. And c is your constant term, so c is the number on the end. So being able to identify a, b, and c is important. And it does need to be in standard form, meaning your quadratic is first, your linear is next, and your constant term is third. That helps you determine your a, b, and c. All right, it says which statements about the discriminant of x squared minus 2x minus 15 are true. Select all that apply. All right, so c equals b over 2 squared, which equals 64. All right, b is negative 2. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1, not 64. All right, for the second one, it says b squared minus 4ac equals 24. All right, so let's check. All right, so this is the same equation here, so we'll just rewrite our a, b, and c. So a equals 1, b equals negative 2, and c equals negative 15. The negative's here, but don't forget that that is negative 15. All right, so now we need to do the discriminant, b squared minus 4ac. So I'm going to plug in my b, so I've got b squared. Remember, parentheses are important. And then plug in a and c as well. All right, negative 2 squared is 4. Negative 4 times negative 15 is plus 60, and that equals 64. So the second one is true. The number 64 tells us the equation has two real solutions. That is true as well. Remember, if you go back up here, okay, two real solutions happens when the discriminant is greater than 0. So when the discriminant is positive, 64 is a positive number, it has two solutions. All right, the number tells us it has 1. The number tells us it has no. So that's not true. Only this one, only the second and third one are correct. All right, in the spreadsheet below, the formula in cell D2 evaluates the discriminant for 4x squared plus 13x plus 9 equals 0. What does the value in cell D2 tell you? All right, this value is positive, so this value tells us that we have two real solutions. This quadratic equation will have two real solutions because the discriminant is positive. All right, match the quadratic equations to the rows they represent in the spreadsheet. All right, the first one is already done for us. So let's look at row 3. Row 3 says negative 4, 13, and 9. So this is our A, our B, and our C. So that comes from the equation with a negative 4, positive 13, and positive 9. So that's going to be this equation here. Goes with row 13. Row 4, positive, negative, positive. So positive, negative, positive. Positive 4, negative 13, and a positive 9. So that goes with row 4. And then we've got 4, 12, and 9. All of them are positive. 4, 12, and 9. And then number 6, our A, B, and C are 4, 13, and 12. I think these are all positive. Yes. All right, so all we're doing is determining where A, B, and C are to match it with the correct equations. All right, it says fill down the formula from cell D3 through D6. Which statements describe the discriminants and the solutions for the equations you found in part D? Select all that apply. All right, the values for D3 through D6 are. All right, so it looks like the first thing we need to do is find the discriminant for the rest of the table. All right, so remember the discriminant, new vocabulary term, b squared minus 4ac is the part under the square root in the quadratic formula. This determines whether you have two real, one real, or no real solutions. All right, so if we're going to use the discriminant to find D3 through D6, we're going to use the A, B, and C in each one given. All right, so let's do D3 first. All right, D3 is going to be B squared is going to be 13 squared minus 4 times A times C. All right, negative 4 is A and 9 is C. All right, let's see what that equals. All right, so we're going to have 13 squared. It's not squared. Let's see, 13 squared minus 4 times negative 4 times 9. And that's going to equal 313. All right, so let's do D4. Okay, let's move this out of the way so we can see our A, B, and C. So we've got 4, negative 13, and 9. So let's plug that in. So our B is negative 13 this time. Negative 13 minus 4 times A times C. A is 4 and 9. So let's look at what that equals. So we're going to have negative 13. So I'm going to put that in parentheses to make sure when I square it, my calculator does the correct operation. So I'm going to have negative 13 squared minus 4 times 9. And that's going to be 25. And then D5. Screen doesn't have very much room, does it? All right, so 4, 12, and 9. All right, so our B is 12, so we're going to do 12 squared minus 4 times A times C. So 4 and 9. So I'm going to have 12 squared minus 4 times A times C. All right, so that one has a discriminant of 0, and then D6, 4, 13, and 12. All right, so we're going to have 13 in the middle, so that's our B. All right, and A is 4, and C is 12. All right, so we're going to do 13 squared. It's positive, so I don't need parentheses unless you just want them. 13 squared minus 4 times A times C. And that one gives us negative 23. All right, so we can see that we got a positive, a 0, and a negative there for our discriminants. All right. Now it says, fill down the formula form for cells D3 through D6. Which statements describe the discriminants and the solutions for the equations you found in Part D? Select all that apply. The values for D3 through D6 are 3, 13, 25, 0, and negative 23. So those are the 4 values we found for the discriminant. This one's not correct because the last one they have is a positive number. The discriminants tell us that 3 equations have 2 real solutions and 1 equation has no real solutions. All right, so 3 equations have 2. That's not true. 2 equations have 2 real. The discriminant tells us that 2 equations have 2 real. That's true. 1 equation has 1 real. That's true because 0 is 1 real. And 1 equation has no real solutions. That comes from the negative. So that one is true as well. The discriminant tells us that 2 equations have 1 real. Nope, that's not true because 2 of them would have equaled 0. All right, so that is all for task 2. If you have any questions about the discriminant, please let me know.